Hi, welcome to our class today. We want to look at a particular question of concern, and this question sometimes you do it more in higher mathematics, where you look at the ideology of reanalysis. In reanalysis, we tend to investigate and prove theorems, trying to say that something is true or maybe false. And maybe we prove by contradiction. To prove things by contradiction, meaning you first of all assume that the reverse is true and try to use the assumption to prove the falsity of what you have said. So I have a question, and this question here is on geometric sequence, and we show you that question in a while. The root of an equation x, and this x is equals to negative n plus the root of n squared minus 4mn. Divide this by 2m, where m, p is a member of R, and this has a positive charge. That's why you can see plus on top of it. Those are positive charges. Now the numbers m and p are in that order. Yeah, you see, for a geometric sequence we have to put them systematically. So the numbers m, n, p in that order form a geometric sequence. So if x is beta, so x is equal to beta or alpha, which one of the following statements is false? So we want to see which of the statement is false. A, we have b, which is a multiple. A gives us alpha, which is a multiple of beta. So beta multiplied by alpha is equals to n over m, and all that squared. That means that you have n squared over m squared. B, we have beta plus alpha, and this is equals to negative m over n, or negative n over m. Either way. We have C, which is equals to beta, a multiple of alpha, which is a member of R. In this case, they have positive charge. And then we have D, option D, P is equals to n squared over m. So how do we know if any of these statements is false? We can only know that by proving the theorem. So come, let's prove if any of these are wrong or so for the solution, what you should know is that for every geometric sequence with maybe A, R as the first term, we need to know the common ratio as per what is given. So in this case, we are given m and p. So you have m, n, and p. This is what we are given in this case. So these are geometric progressions, because we are told they are geometric sequence. So this implies that A is the first term. So if A is the first term, if A is the first term, it is then equal to m, right? And then we can take AR to be a second term, since it is geometric sequence. So if AR is our second term, it must be equal to n by geometric sequence. Right, and we can take the third term. Since this second term is AR, the third term is AR squared. So AR squared must be equal to P as what we have. So now we have M and P, and we have taken A, we have taken M, we have taken N, and we have taken P. So A is equals to M, AR is equals to N and AR squared is equals to P. These are assumptions that you must do in geometric sequence. Now let's solve and see which of the statement is true. Now if R is equal to AR, what we have here, then we can divide this by A. If I divide that by A, I will simply get AR squared. This is AR squared over AR. Just cross multiply that. This implies that I can get this to be equals to N over, this is N over M, which is equal to P over N. So what this tells you is that we will have N squared in this case. N squared to be equal to PM. So what is P? P is going to be N squared over M. So this statement is true, not false. So let's look at the options. We have P is equals to N squared over M. D is correct. Now let's look at, maybe we can prove again and see which other one we can assume to be wrong in this case. If I take N squared, I will have it to be 4 MP, because it has appeared 4 times in terms of the geometric sequence, and this is N squared, right? Minus 4M, then we have N squared over M. This gives me N squared minus 4N squared. This is equals to negative 3N squared. So X is going to be negative N, because we are told it is negative N. So negative N in this case, plus or minus the root of what we have here is negative 3N. We put it, it is negative 3. We have negative 3N squared. All this divide by 2M. So we have 2M. So this, in essence, if I simplify, I will simply get negative N plus or minus IN, the root of 3 divided by 2M, which implies that this will be negative N plus IN, the root of 3 divided by 2M. Or I can rewrite this to be negative N negative IN, then root 3 over 2M. Either way. So what this tells you is that if I let beta to be equal to negative N plus or minus IN, the root of 3 divided by 2M. And maybe I let alpha, because we have beta and alpha. If I let alpha to be equal to negative N minus in the root of 3 divided by 2m. The first option that we have says that beta multiplied by alpha is equals to n over m squared. That is the first option A. Option A. So we have beta by alpha. So beta by alpha is equals to negative n plus, because we know what is beta, in the root of 3. Divide this by 2m. Then we multiply this by alpha. We know what is alpha. Negative n, negative in root 3 over 2m. Now, if I simplify this and multiply them together, I will simply have n by n gives me n squared plus 3 n squared divided by 2 gives me 4. So it is 4m squared, which I can simplify to get n over m squared. So which of the option n over m squared? So this first statement is true. Let's look at option B. Option B says that beta, can see beta plus alpha is equals to negative m over n. Beta plus alpha is negative m over n. So let's look at it together, beta, and then we add. So this implies that our beta is negative n plus in the root of 3 divided by 2m plus alpha negative n negative in the root of 3 divided by 2m. So we add that together. If we add, we will simply get, this is negative n, so that gives me negative 2n. Then we will simply have 2m, which I can simplify to get negative n over m. So negative n over m is here. So this is true. Let's look at option C. Option C says that beta times alpha is a member of R, and those are all positive charges. So I can have it here, C. So beta alpha, a member of R, positive. So what does that mean? Let me write my beta, negative n plus I n the root of 3 divided by 2m. Then I have my alpha. So my alpha is negative n, negative I n the root of 3 divided by 2m. That is my alpha. So if I have these two, It is obvious because these are two multiples cannot be a member of each other. Because you have 2m and you have 2m. And it's not just a multiple, they are a member of these three numbers. So this is false. This statement is false. In a sense that beta alpha is not a member. We are told they are a member, but now I am concluding by crossing this membership. They are not a member of R in terms of their real numbers. And option D already shown that n over m is equals to p over n. This implies that n squared is equals to pm. In this case, p is nothing but n squared over m. So option D is correct. So the only false we have here is C. Beta alpha is not a member of R.